Welcome everyone to DevOps Deep Dive. I'm Jordan Taylor, and I'm here with Alex Chen, a senior DevOps engineer who's been working with Kubernetes for, over 5 years. Today we're diving into something that, trips up a lot of newcomers. It's understanding Kubernetes structures and how they all fit together. Alex, thanks for joining us.
Thanks for having me, Jordan. This is definitely one of my favorite topics because, once you understand the hierarchy, everything else in Kubernetes just starts to make sense. It's like learning the foundation before you can even think about building the house.
A perfect analogy. So let's start at ground zero. When people hear Kubernetes or K8s, what exactly are we talking about? Let's demystify it.
Great question. At its heart, Kubernetes is an open source platform for container orchestration. But to put that in simple terms, think of it as your intelligent operations manager that never sleeps. It automates the deployment, scaling, and management of your applications. It's constantly making sure everything is running exactly how you want it to.
Right.
It's handling failures, scaling up when traffic spikes, and scaling back down when things quiet down.
That sounds incredibly powerful, but also complex. You mentioned a hierarchy. I think breaking that down would be the best way to grasp this.
Absolutely. It all follows a nested structure. From largest to smallest, you have the cluster, then the namespace, then the pod, and finally, the container. The real insight here is that while your application code runs inside a container, that container is always wrapped in these increasingly larger organizational structures to manage it effectively.
Okay, so let's start at the bottom and work our way up. Tell us about the humble container. What makes it so special in this world?
The container is a true game changer. It's a lightweight, portable environment that packages your application with all its dependencies. Libraries, settings, everything. They are image-based, which means you build it once and can run it anywhere, from your laptop to the cloud. They also provide process isolation, so your app runs in its own protected bubble.
Right. So if I have a web application, I package it up into one of these containers. But you're saying that's not what I actually deploy in Kubernetes?
Exactly. This is the first key concept that trips people up. In Kubernetes, you don't deploy containers directly. You deploy pods, which are essentially wrappers around one or more containers.
And why the extra layer? Why not just work with the containers?
It's all about creating a single manageable unit. A pod is the smallest thing you can actually deploy in Kubernetes. All containers inside a single pod share resources, the same IP address, network, and any storage volumes. They can even talk to each other as if they were on the same machine. This allows for some really powerful patterns.
That's interesting. So it's not always one container per pod. Could you give us a real-world example of when you'd put multiple containers into one pod?
For sure. A classic example is the sidecar pattern. Imagine your main container is running your web app. You could add a second container, a sidecar, which its only job is to collect logs from the main app and ship them off to a central logging system. Since they're in the same pod, the sidecar can easily access the log files, and they scale up and down together as a single unit. It's an elegant way to add functionality without bloating your main application.
That is a clever design. Okay, so we have containers inside pods. Let's move up the hierarchy. What's the next level?
Next up are namespaces. The best way to think of a namespace is as a virtual cluster inside your real physical cluster.
Okay.
They create logical boundaries to organize all your pods and other resources. It's like having different departments in a company.
Right.
The marketing team's projects are kept separate from the engineering teams, even though they all exist within the same organization.
So in practice, I could use namespaces to create completely separate environments for, say, development, staging, and production, all running on the same physical hardware.
That's one of the most common and powerful uses. You get total environment separation, which is crucial for safety and organization.
Yeah.
But you're still sharing the underlying cluster infrastructure, which is very efficient.
Okay, that makes sense. So that brings us to the top level, the cluster.
what does a complete Kubernetes cluster consist of? The cluster is the whole thing, your entire Kubernetes environment. It's made of two main parts, the control plane and the worker nodes. The control plane is the brain of the operation.
The brain.
It has the API server you talk to, the scheduler that decides where to place pods, and the database that stores the state of the entire system.
And I assume the worker nodes are where the action happens.
Exactly. The worker nodes are the machines, virtual or physical, where your pods and containers actually run. They do the heavy lifting, managed and directed by the control plane. The whole system is designed so that all these components can communicate seamlessly, creating one cohesive, powerful platform.
Now, you mentioned something earlier that I want to circle back to, this idea of a desired state. That seems to be the philosophical core of how this all works. Intriguing. Can you expand on that?
This is the most important takeaway for anyone starting out. With Kubernetes, you don't typically tell it, what to do step by step. You declare what you want. You write a file that says, I want 3 replicas of my web application with these specific resource limits. You hand that declaration to the cluster. From that point on, a set of automated processes called controllers work relentlessly to make sure reality matches your declaration. If a pod crashes, the controller sees that the actual state, 2 pods, doesn't match the desired state, 3 pods, and it just fixes it. It automatically launches a new one.
It's a shift from giving orders to describing an outcome. That's a profound difference. Alex, this has been incredibly enlightening. Before we go, what's one final piece of encouragement you can offer our listeners who might be feeling a little overwhelmed right now?
Don't try to learn it all at once. Start with the basics we covered.
Yeah.
Understand what a container is, then a pod, then a namespace. Get your hands dirty. Set up a small local cluster with a tool like Minikube and just experiment. The journey to mastering Kubernetes is a marathon, not a sprint. But every step you take builds on the last, and it's an incredibly rewarding skill to have.
Fantastic advice. Thank you so much, Alex, for breaking down these complex concepts so clearly. To our listeners, remember that understanding this hierarchy is the foundation for everything else in the world of container orchestration. Now, here's a question we'd like you to think about. As automation like Kubernetes increasingly manages our infrastructure based on desired states, how does our role as engineers change from being system operators to system architects? Until next time, this is Jordan Taylor saying, keep those containers orchestrated. Thanks, everyone, and happy Kuberneting!